Hey guys, how's everything going? Today let's take a look at number 64, minimum path sum. We're given an MN grid filled with non-negative numbers. Find a path from top left to bottom right which minimizes the sum of all numbers along its path. We can move either down or right at any point in the time. So yeah, actually we did some similar questions such as number 62, unique paths, which determines whether we can determines how many unique paths we have to move from top to the bottom, right? And so it's kind of similar. I'll just copy paste my solution here. If you're interested, please search on my channel, which is search on my channel for 62 unique paths. There will be a detailed explanation there. I'll just first copy my original solution here. So different from the previous problem, in the previous one, we are going to count the possible unique paths, but here we need to return the path which minimize the sum. Minimize the sum. Yeah, and the problem seems to be similar because the minimum sum for the path to this point might be thereby two possibilities, which is from this one or from this two, right? So it would be the minimum path to this one and the minimum to the point to this two. So the minimum between these two is the plus this one will be the final result. So that reminds us that rather than we save the possible this possible what we the possible paths count, we can store the minimum sum and its path, right? That would be great, right? So we just like 62, we store not the count but sum path, something like this. Yeah, because that's the case, we will okay, wait a minute, how should we start? We could initialize the first row with 0, but we need to calculate the path. So just as we did before, we fill it with 0. Fill it with 0, with map it to sum is 0, path is empty. So this is right? And for the first, because we start from the first, oh yeah, we don't need to handle the first one because even it's 0, it will be one step to here. Yeah. Because it's minimum. Okay, my bad. So the sum would be, yeah, the sum should be the number positive infinity. Infinity. Okay, and then for each number here, we use this graph. Okay, we will check the sum from top and from left, which one is smaller. If it's smaller, we took that in and update the path. Yeah, kind of simple. Sure, let's do it. So the iteration will be, okay, wait a minute. We are given a matrix just like that one. So Okay. Again, I will change this to a for loop, which is simpler for me to understand. Okay, this is n plus plus. I change this to j. So the first one is also need to be considered. So yeah, we need to do some checks here. Okay, so so we need to check which one is smaller, right? From this one or from the previous one. Like if we're going to these, we need to from the left or from the top. So okay, if the left one, if left, we just say we just define it. If const left equals if j is the first one, there will be no left, so it will be infinity. We choose the minimum, so we make it to infinity. If it's 0, then it should be infinity and no is nothing there. Yeah, if not, then it should be dp j minus 1 constant top equals dp j, right? Yeah. But for the first one for the first number in the top left, will be infinity and the top will be infinity. That's a problem, right? So the left should be, yeah, dp0 should be 0. Cool. There should be no problem. And then we will compare them, right? Okay, if left 0 is smaller or equal to top 0, it doesn't matter which path there is. Huh? Find a path. We output 7. So 7 is the sum, right? We don't need to give this path, but only the sum. Okay, we don't need to store the array, so we just update it to infinity. Okay, would be much simpler. Okay, if left is smaller than top, then left should be picked. So dpj updated to left plus grid ij. If top is small, then dpj equals top plus grid ij. Yeah, we can actually rewrite it into a ternary equals this plus math mean left and top. It will be simpler. Okay, after that, so after everything is done, we can finally return dp m minus 1. Yeah, this should work. It's pretty straightforward. It's not work. M is not defined. M. Oh. yeah. By the way, the time and the space is all as the same as before. Run the code again. Hope it pass. Submit. I made a mistake that I thought that because I saw the explanation here, I thought that I need to return the final paths, and so we need to store the sum and the array as the data point. But it turns out that we only need to return the sum, so it makes the problem similar, easier. But if we are asked to do that, to return the path, it will be just the same, right? We just transform this number into array. The first one is itself, and the second one is the path. So here we compare the first item in array and update it, and push the item into the second item in array, and that is the path. Cool. So anyway, so that's all for this problem. Hope it helps you first to some extent, and see you next time. Bye bye.